Welcome to the Snow Day Bond lecture for BU 283. The first ClassQ question is about this State of Arkansas bond. So the issuer is the State of Arkansas. The issue date is July 1st, 1861. The maturity date is printed here 5 years after July 1st, 1861, so 1866. The face value is $20. So the holder of the bond will receive $20 from the state of Arkansas in July 1866. And then across the top and bottom are these little coupons. And if you look closely, each one's for 80 cents. And they're all dated with different dates at 6-month intervals. So the first one is January 1st, 1862, 6 months after issue of the bond. So the bondholder would receive 10 coupons of 80 cents apiece every 6 months, and then at maturity, the face value of $20. And the question is, did the holder receive the face value of the bond at maturity? This video will answer that question for us.
The American Civil War was a civil war in the United States from 1861 to 1865, fought between northern states loyal to the Union and southern states that had seceded from the Union to form the Confederate States of America. The Civil War began primarily as a result of the long-standing controversy over the enslavement of black people. War broke out in April 1861, when secessionist forces attacked Fort Sumter in South Carolina, just over a month after Abraham Lincoln had been inaugurated as the President of the United States. The Loyalists of the Union in the North, which also included some geographically western and southern states, proclaimed support for the Constitution. They faced secessionists of the Confederate States in the South, who advocated for the states' rights to uphold slavery. Of the 34 U.S. states in February 1861, 7 southern slaveholding states were declared by their state governments to have seceded from the country, and the Confederate States of America was organized in rebellion against the U.S. constitutional government. The Confederacy grew to control at least a majority of territory in 11 states, and it claimed the additional states of Kentucky and Missouri by assertions from native secessionists fleeing Union authority. These states were given full representation in the Confederate Congress throughout the Civil War. The 2 remaining slaveholding states, Delaware and Maryland, were invited to join the Confederacy, but nothing substantial developed due to intervention by federal troops. The Confederate States were never diplomatically recognized as a joint entity by the government of the United States, nor by that of any foreign country. The states that remained loyal to the U.S. were known as the Union. The Union and the Confederacy quickly raised volunteer and conscription armies that fought mostly in the South for 4 years. Intense combat left between 620,000 and 750,000 people dead. The Civil War remains the deadliest military conflict in American history and accounted for more American military deaths than all other wars combined until the Vietnam War. The war effectively ended on April 9, 1865, when Confederate General Robert E. Lee surrendered to Union General Ulysses S. Grant at the Battle of Appomattox Courthouse. Confederate generals throughout the southern states followed suit, the last surrender on land occurring June 23rd. Much of the South's infrastructure was destroyed, especially its railroads. The Confederacy collapsed, slavery was abolished, and 4 million black slaves were freed. Vidipedia.com is the YouTube of Wikipedia. Every topic is simply explained in a short video. If you like our video, please like, share, and subscribe to our channel for more videos like this. Please also...
As you can gather from the video, the Confederacy lost the Civil War. The state of Arkansas was part of the Confederacy, and so they defaulted on this bond. They did not pay the holder the $20 or the last few coupons. A 2-year zero coupon bond has a face value of $1,000 and a price of $890. A zero coupon bond just pays a face value and has no intermediate coupons. So we're looking for the interest rate on this, and we're going to use the variable K now when we talk about interest rates rather than I. And in fact, with bonds, this interest rate is known as the yield on the bond. Well, we can use our future value formula to solve for this because there's compound growth here. So 1 plus k to the power 2. And we learned how to solve this problem in chapter 3. It's going to be the future value over the present value. The future value is just the face value over the price to the 1/2. So that's going to be 1,000 divided by 890 to the 1/2 minus 1 over k. In the US, this is called the spot rate. And in Canada, we call it the yield on a 2-year Government of Canada zero coupon bond. So we don't have a good short form in Canada. The label really describes what it is. This is kind of the building block of bonds because there's no default risk with a government bond, or at least with a U.S. government bond and maybe a Canadian bond. We have here a table of bond prices over different maturities. These are all government zero coupon bonds, each one with a face value of $100. And in the right-hand column, we're calculating the yield to maturity. The yield on the first one, the 1-year Treasury spot rate, or the yield on a 1-year zero coupon government bond, is going to be the face value minus the price over the price. And you can probably guess from the pattern of returns in the table that that's going to be 1%. If we graphed this information, we call it the yield curve. We have maturity on the x-axis and yields on the y-axis. And we've got maturities 1 through 5. So we're graphing the yields on these various zero coupon bonds. And the yield curve would look like this with an upward slope. The table is called the term structure of interest rates, and the graph is the yield curve. To answer question 5, we need to go on a bit of a virtual magic school bus trip. We're going to go to the Bank of Canada website, go to Statistics, Interest Rates, and Yield Curves for Zero Coupon Bonds. And we just want the most recent data. I'm going to put in January 1st to January 26th. And that downloads a spreadsheet for us. Here's what the sheet looks like. The data is not quite up to date. The most recent data is for January 7th. I'm going to delete everything else. So what we've got here are yields on Government of Canada zero coupon bonds. Column B, the way you read that, is zero coupon for a quarter of a year maturity. And the value in cell B2 is the yield on that 90-day T-bill, so 2.19%. And then the next column is a half year, then 3/4 of a year, and 1 year. And this goes out to 30 years. I'm going to turn that into a column by using a transpose. And that's going to make it easier to work with. So here's the data, and now we can graph this and create the yield curve. And there is our yield curve for January 7th, 2026, yields on Government of Canada zero coupon bonds from a quarter year to 30 years maturity. And you can see that the graph is upward sloping, which we call the normal shape. And what's the yield on the 1 year? Well, that's this cell right here, B5, and Question 6 asks us to calculate the nominal rate of interest given the real rate and expected inflation. Well, we know from the Fisher equation that 1 plus the nominal is equal to 1 plus real times 1 plus inflation. So if we simplify that, the nominal is the real rate plus inflation plus this little product term. So that's going to be, in my example, 3.5 plus 0.032, and the product term is going to be super small. So it's very close to the sum of the real rate and inflation. Where does this come from? Well, imagine a farmer who has 100 bushels of wheat at time 0, and let's say the price of wheat is $1 per bushel. And let's say the real rate is 10% to make the numbers easy. So if the farmer plants the wheat, that's where the real return comes in. He'll have 110 bushels next year at harvest. But let's say that there's inflation in this economy at the rate of 5%. That means prices are rising at the rate of 5%. So we know the price of a bushel of wheat will be $1.05. The value of the harvest at date 1 is going to be $115.50. And of course, the value of the wheat at time 0 is just 100. So if there was a banker in town that wanted to entice the farmer not to farm, the banker would have to offer a nominal return of $15.50 to make the farmer equally as wealthy as if he had farmed. And of course, that's just going to be the real rate plus inflation plus that product term. Well, you do this in decimal form. You don't do it in percentage form, but you get the idea. The next few questions show the relationships between short-term and long-term interest rates under the expectations hypothesis. So we're building to a conclusion, and it's going to take a few questions to get there. We'll use the simplest possible framework possible, a 2-year timeline with a 1-year bond and a 2-year bond. So on this timeline, this arrow represents the 1-year bond with yield K1, and the longer arrow underneath represents the 2-year bond with yield K2. And then we also know that the government will issue a 1-year bond next year, and we have an expectation about what that yield will be, and that's E of K1. Now, if you wanted to invest over a 2-year horizon, how would you do that? We're going to talk about 2 strategies. One, the lock-in, and that's the idea that you just buy the 2-year and then receive the face value in 2 years' time, and you're going to get K2 for 2 years. We call it the lock-in because you've locked in your yield. The other strategy we're going to look at is the rollover, where you buy the 1-year bond and then receive its face value, and then you buy at year 1 a second 1-year bond and receive its face value. So you roll your money over. Question 8 gives us some prices on the 1- and 2-year bonds, and question 8 is going to explore the lock-in strategy, and it asks us to calculate the yield on the 2-year 0 coupon bond. Well, we know the 2-year yield is just the face value over the price to the 1/2 minus 1, where the face value is $100. Questions 9 and 10 explore the rollover. What we want to do here is have a horse race between the rollover and the lock-in. In the lock-in strategy, we invested $87.34, and 2 years later, we had $100, the face value of the 2-year bond. To make this a fair race, we want to invest $87.34 in the rollover. The only problem is the one-year bond costs $94.34. We don't have enough money to buy that bond. So what we're going to assume is that you can buy fractions of a bond. So the fraction that we're going to buy is just $87.34, the amount of money we want to invest over the price of a one-year bond. So that's 0.9258 of one bond. And then the question is, how much money will we have when that bond matures in 1 year? Well, there's two ways to think about this. We know that if we buy one-year bond, the face value is going to be the price times the 1 year spot rate, right? So that's 94.34 times the yield. Well, we're not actually going to buy a full bond. We're going to buy 0.9258 of a bond. And then that's going to grow at 6%. And that's going to work out to $92.58 as the face value. Another way to think about this is we bought 0.9258 of the bond, and the face value of the bond is 100. So we're going to get that fraction of the face value, which is going to be $92.58. Question 10 is the second leg of the rollover. So just to catch you up, we invested $87.34 when we bought the fraction 0.9258 of one bond, and then that gave us $92.58 of face value at date 1 for a yield of 6%. Now we're standing at date 1 with this $92.58, and the government is auctioning a new one-year bond. And the yield on this one-year bond is 8%. So interest rates have gone up. Turns out the price of the new bond is $92.59. So we can afford one. Well, we're just a penny shy, but assume we find a penny on the ground. And that's going to mature at date 2. And the question is, how much money will you have? Well, you did buy a whole bond. Questions 11 and 12 now allow us to use the earlier questions to produce an equation that characterizes equilibrium in the bond market. And equilibrium occurs when there's no advantage to the rollover versus the lock-in, that both produce the same outcome. And that's what we saw in the last three examples. Was the lock-in, we invested $87.34, and 2 years later we had 100. With the rollover, we got the same outcome. We put $87.34 into it, rolled it over after 1 year, and then that second bond matured with a full face value of 100. So we got exactly the same outcome. So there's an equality here. These numbers are in equilibrium, and we need a formula or an equation that characterizes that equilibrium. Well, first we're going to do the lock-in. That's what this question 11 is asking. So again, we're going to assume fractional bond investments. If we could put $1 in the lock-in, how would we characterize what we have after 2 years? And I'm going to put it to you that B is the correct answer. So the future value after 2 years is going to be our investment times 1 plus the 2-year yield squared. So the key here is this 2-year yield. Now we need an expression for the rollover. If we put $1 in the rollover, the future value after 1 year is just going to be that $1 times 1 plus the 1-year yield. When that matures, we invest it for the second year at the 1-year spot rate, which we denote as E of K1. So what we're going to have at the end of 2 years is what we started year 2 with, the dollar times 1 plus K1 times 1 plus E of K1. So what does equilibrium look like? Well, in equilibrium, the future value of the lock-in should equal the future value of the rollover. So what we get is dropping the 1. 1 plus the 2-year spot rate squared is equal to 1 plus the 1-year spot rate times 1 plus the expected future spot rate. Now we're making a pretty strong behavioral assumption here under the expectations hypothesis. We're assuming that investors don't have a preference for lock-in or rollover, that if they produce the same outcome, you don't care one way or the other. There's another theory, the maturity preference theory, that does make an assumption about preference, but under expectations, we assume investors are indifferent. And so this is the equilibrium under the expectations hypothesis, that you ought to have the same outcome under the two strategies, because if you didn't, you'd always pick the one with the higher future value. This expression gives us a relationship between long interest rates, short interest rates, and expected future interest rates. So we could simplify this for K2, and we'd have the square root of 1 plus the 1-year spot times 1 plus the expected future spot minus 1. So what we learn from this is that the longer-term interest rate depends on the short-term interest rate and the expectations of future interest rates. So expectations definitely play a role in determining the shape of the yield curve, because the shape of the yield curve is just how big K2 is vis-a-vis K1, right? Don't forget the yield curve. In our little example here, if K2 is bigger than K1, then we get an upward sloping yield curve. But we know something about the expected future spot rate here vis-a-vis K1 from this shape. In our example, remember, this was 7%, the 1 year was 6%, and do you recall what the expected future spot rate was? And how did that relate to K1? That ought to help you answer question 13.